But as you've heard, to make CCS possible to be deployed on a large scale, we would need major investments. And in keeping with the IEA scenarios, CCS is expected to be deployed on a large scale after 2020. But that's a supposition which will not convert into reality unless we start taking some actions urgently. I was asking whether we have an official from Statoil Hydro over here, because I had the privilege of interacting with their top management a few years ago. And I told them, with the price of oil being what it is and the healthy profits that they're generating, they should be investing much more in the development of CCS technology, particularly in the nature of demonstration projects. Because once we have a large number of demonstration projects, we would be able to dispel the concerns and even suspicions of the public on some of the negative impacts that they see coming from CCS. So, as the IEA has, the IPCC has estimated, to make this happen, it's possible that we may have to spend up to $600 billion to see that CCS projects really get utilized in the period 2010 to 2030. And we've estimated a total investment of $2.5 to $3 trillion between now and 2050. As you're probably aware, the IPCC produced a special report on carbon capture and storage, which came out about 5 years ago. And we carried out a detailed assessment of the technical aspects of carbon capture and storage and came up with some projections of where this would go in the future, particularly in terms of economic viability. And I might mention, taking that particular report into account and what we have seen as the development of other mitigation options, it's singularly clear that there's no unique technology that will provide the range of emissions reductions that are required. And Dr. Sweeney has already mentioned that. Now, the CCS process, as you know, involves several steps. There's first the separation of CO2, then transport to a storage location, and finally the storage and long-term isolation from the atmosphere. And I think each one of these requires very careful attention and sustained efforts to develop that. And CCS can be used so that greenhouse gases can be reduced and captured, particularly from large point sources. And therefore, thermal power plants using coal become excellent candidates for doing so. But what's really important is to see that you have a reasonably contiguous possibility of storage from the point where carbon is captured. And I think there are really three types of CO2 capture systems: those that are post-combustion, pre-combustion, and oxy-fuel combustion. And I think we should also be aware of the fact that there are three possibilities for storage. One is, of course, in geological formations. The other is ocean storage and the generation of silicate mineral deposits. I was in Iceland recently, and I heard about this very interesting project that they are carrying out in Iceland in collaboration with a French institution, where essentially carbon dioxide is being injected into the ground to convert certain rocks, and these are basically formations from volcanic activity, and these are being converted into limestone, and therefore you're really converting it into a useful material. Now, may I say that ocean storage and its impacts are still in a research phase, and we must remember to fiddle around with anything with the oceans can be extremely hazardous. We have no idea of what the kinds of negative externalities we might be imposing through those solutions. Similarly, silicate mineral deposits are also currently in the research phase. So, For the time being, what seems most attractive is geological storage. And I think this is where we need to look at some demonstration projects and see how we might be able to cut down on costs. I don't want to take much longer than this, but let me conclude by saying that we really didn't have good data in the IPCC special report that we brought out, and we came up with a range of increase in cost of power generation from those projects where you might be able to extract carbon dioxide and use CCS. And this range was from 20